Welcome to Probability and Statistics. In this lecture video 10.1 to 10.5, we want to talk about something called the hypothesis testing. Okay, so we kind of wrap around this this whole semester where we kind of go in a circle. Some of the stuff that I talk about at the beginning of the lecture video series, talking about how accurate, some of these statistical number is when people put those statistical number out there on the newspaper, on the websites, or in the news. Okay, so for example, labor statistics. Okay, this is from the Bureau of Labor Statistics database. Your unemployment rate. Okay, unemployment rate for United States. So if you look at this table right here, coming up from the government, as you can see, as of March of 2017, the national unemployment rate is at 4.5%. If you think back on during the recession time, back in 2009, the unemployment rate was over 10%. So the question is, how accurate are these statistical numbers that the government present to us? So the way to test these numbers, whatever people tell us doesn't mean it's always true. So a way to test it is called the hypothesis testing. All right. So couple new words here. A hypothesis is referring to a statement, regarding to a characteristic of one or more populations. So when we say the unemployment rate as of March 2017 is 4.5%, so what we want to do is thinking about testing for that number. So it's a statement regarding the characteristic of one or more populations. What is so-called a null hypothesis, which is denoted as H null, is a statement regarding the value of population parameter. Like population unemployment rate is at 4.5%. That is to be tested. So we're going to test that 4.5%, for example, and always contains the equal sign. So the government is saying, what the government is saying is unemployment rate is 4.5%. So that is the null hypothesis. So the null hypothesis is percentage, population proportion P, we'll talk about this, is at 4.5%, 0.045. Null hypothesis is always contains the equal sign. The null hypothesis is assuming to be true until indicated otherwise. So this is the number we're trying to test. The alternative hypothesis, H of alternative, is a statement regarding the value of a population parameter that we are trying to find evidence to support. So for example, if you believe the unemployment rate is less than 4.5%, then you will say, my alternative hypothesis, population proportion P, is less than 0.045. So this is what we are trying to find evidence to support. This is what the big government tells us. So this is them, alternative is us. We are the one trying to prove that maybe their number is not as accurate. All right. In this video, I will use this word quite a bit. Something called a test statistic. It's a value representing the number of standard deviations that the simple mean is from the assumed mean. I'm using the word mean. I can actually test for mean. I can test for population proportion P. I can test for what's another parameter we talked about before? Mean, population proportion P, and I can also testing for variance or standard deviation. Okay, so we will talk about all that. We'll do all those tests in this lecture video. Okay, very important fact. You never say we accept the null hypothesis. We never say we accept what they are saying is true. Instead, we say we fail to reject the null hypothesis. Okay, very important wording. Never say what, never say what the government told us is correct. Instead, we say we fail to what? Reject what they are saying. All right. There are three basic ways to set up your hypothesis testing. Okay, I can have a two-tail test. All right, where the null hypothesis is always equal to, or it's always equal using an equal sign. If it's a two-tail test, the alternative hypothesis is always not equal to. Not equal to is two-tail test. All right, left-tail test will be less than. Okay, so alternative will be less than. Less than means left tail. Right tail test will be where the alternative is going to be greater than, so that will give me a right tail test. So we will draw these pictures just in a minute. All right, so let's kind of playing on words a little bit. I want to show you how to write out these hypotheses by reading some of these examples. So for example, a sample of 900 computer chips revealed that 58% of the chips fail in the first 1,000 hours after their use. So the company's promotional literature claims that, so this is them, they are claiming that 62% fail in the first 1,000 hours. Okay, so this is them. So the null hypothesis, okay, this is percentage, so I use population proportion P. They're saying it fails, 62% fail. Okay, but the truth is, okay, a sample 900 shows 58% fail. All right. Is there sufficient evidence that 0.01 level, so the 0.01 level to dispute the company's claim? All right. So what they are saying is fail at 62% fail. So what are we saying? The problem never indicated whether it is greater than or less than the 62%. So when they don't do that, we say it is not equal to 62%. Okay, so this 58% right here is actually a sample of 900 computer. What we need to test is what they are saying. Okay, all right, let's do another one. Maybe it'll make a little bit more sense. Oh, by the way, this 0.01 level is actually our alpha. Okay, so when we talk about confidence interval before, confidence interval is referring to the middle of our normal curve. Okay, so if this is 99% confidence level, so that means outside the confidence level, which is our alpha, is actually 0.01. So confidence interval is about looking at the center parts of the normal curve. Hypothesis testing is actually looking at the tail parts of the normal curve. Okay. All right, let's try another one. Maybe this will make a little bit more sense. A manufacturer of chocolate chip would like to know whether its bag filling machine works correctly at 440 gram setting. Is there sufficient evidence at 0.02 level that the bag are underfilled? bags are underfilled. Alright, state the null and alternative hypothesis. So all we're doing right now is writing down the null and alternative hypothesis. So what are they saying? They are saying, okay, their machine, the mean of their machine is set at 440. Okay. And they want to test that 440 gram. So the mean, okay, underfilling means the alternative is going to try to test what is actually underfilled. So they believe it's less than 440 gram. Okay, so basically what it's saying is the company set the setting at 440 gram. Okay, but they are feeling, okay, it's underfilled. These bags are underfilled. So when they trying to test themselves, okay, the alternative will be trying to find evidence to support it's actually less than 440 grams. All right. So this is actually using mean, the mean of the setting. Average weight is at 440 grams. All right. An engineer has designed a valve that will regulate water pressure on an automobile engine. The valve was tested on 170 engines, and the mean pressure, see that word mean, so that means our hypothesis testing is testing for the mean. Okay, and the mean pressure was 6.7. Assuming the standard deviation is known to be at 1, if the valve was supposedly designed to produce a mean pressure 6.6, is there sufficient evidence to support at the 0.05 level that the valve performed above specification? Alright, so the 6.7 come from when they do the actual test. Okay, alright, the engine, this valve was designed to perform at mean pressure 6.6 pounds per square inch. So the claim is, the null hypothesis is, the mean pressure is supposed to be at 6.6. Okay, so when they do the test, all right, they found that when they do the test themselves, 170 engines, the mean pressure was 6.7. So the alternative hypothesis got to be, is the valve performing above the 6.6? Okay, that's what it's actually trying to say. All right, be careful now. One part of this problem, okay, is coming from the testing of themselves. Okay, what we are looking for is, for the null hypothesis is, okay, what it's supposed to be, okay, what it's supposed to design to be, what the setting was supposed to be, okay, what the company promotion literature claims what it's supposed to be. Okay, so a lot of times companies test themselves. Okay, test themselves. All right, so that's null and alternative hypothesis. Okay, we'll do every problem that we deal with. We have to do something like this. At the end of every problem that we are going to do is a conclusion. All right, so this example is about how do you suppose to write out the solution. Using traditional method, it takes 96 hours to receive an advanced flying lesson. Okay, a new training technique using computer aid instruction has been proposed. A researcher believes that the new technique may lengthen the training time and decides to perform a hypothesis test. Okay, so after testing 100 students, the researcher, see, this is a key word, the researcher failed to reject the null hypothesis at 0.02 level of significance. All right. So they were saying, so what it's saying is it's supposed to be 96 hours. So that's the null hypothesis. A researcher believed using this new technique of training, okay, will lengthen the training time to be more than 96 hours. But it turns out, okay, that the researcher, fails to reject. Okay, failed to reject means, let me go back on the wording here. Okay, rather than say accept the null hypothesis. Okay, if we cannot find evidence to support our claim, we say we fail to reject the null hypothesis. If I cannot find evidence to support what I'm claiming, what I'm trying to test, we say we fail to reject. So, the reason why we fail to reject is because there is not enough sufficient evidence, okay, to indicating that the new training technique lengthen the time. Okay, we fail to reject we fail to reject the 96 hour is because we do not have sufficient evidence to support the alternative hypothesis. Okay, let's try another one. Okay, the way how we say the conclusion. A newsletter publisher believed that 36% of a reader owns a laptop. Okay, a testing firm believed this is inaccurate and perform a test to dispute the publisher's claim. Okay, so the newsletter publisher is them, which is the null hypothesis. The testing firm is the alternative. So after performing a test, after this testing firm perform a test at 0.01 level of significance, okay, the testing firm decide to reject the null hypothesis. So if they reject the null hypothesis, that means they do find enough evidence, okay, that it is not 36%. Okay, so let me go back up here real quick. All right, the flying lessons, the null hypothesis, okay, the mean hours was supposed to be 96 hours. If we write out the null and the alternative hypothesis, all right, and the researcher believe what is supposed to lengthen it. So the researcher believe it's supposed to be more than 96 hours, but it turns out the researcher failed to reject the 96 hours because it does not find sufficient evidence. So this problem, the newsletter publisher saying, okay, the percent of readers, okay, owns a laptop is at 36%. A testing firm, which is the alternative, okay, believe that is supposed to be, well, it doesn't say it's supposed to be more than 36% or less than 36%. So if it does not say that, all that's saying is not equal to 36%. Okay, so just like the 4.5% unemployment rate, what would be your belief? Do you believe the unemployment rate is more than 4.5%, less than 4.5%, or it's just not going to be equal to 4.5%? Okay, so there are three ways: two-tail test, left tail, and right tail test. So from reading these problems, okay, if it doesn't say anything sounds like greater than or less than, then all we're going to do is saying what is not equal to, because not equal to will make it a two-tail test. Okay, so they reject the null hypothesis because the testing firm did find sufficient evidence, okay, to support that it is not 36%. All right. Before we begin to do any testing, okay, I would like to show you the different types of errors, okay, called the type 1 and type 2 error. So if the conclusion is do not reject the null hypothesis, and in fact the reality is the null hypothesis is true, that will be a correct conclusion. So what is the type 1 error is saying? We reject the null hypothesis, but in fact the null hypothesis is true. That would be called a type 1 error. Okay. Type 2 error is where we fail to reject the null hypothesis. Okay, we fail to reject the null hypothesis, but in reality, the alternative, what we tested, is actually correct. So when the alternative is correct, but we end up failing to reject, okay, then that's called a type 2 error. Okay, so things like that does happen. Type 1, type 2 error does happen, because there is one thing that I have not yet mentioning, is this level of significance. I've been telling you what alpha is. This 0.01, the 0.02 level, they are called alpha, and all along I've been saying alpha is the area to the right. Sometimes it can be the to the right. This is where it's getting confusing, because when we say z sub alpha over 2 before, we're saying that alpha is the area to the right, but in reality it can be viewed as the area on the tails. So when we did a two-tailed, so when we're dealing with two tails, that's why we have to divide it by 2. Okay, but right now alpha is being viewed as the level of significance, okay, when we talk about hypothesis testing. But again, they are still representing areas, okay. In a different context, they're referring to area, okay, on the tails. All right, in this context, under hypothesis testing, these alpha are called the level of significance. All right. So the level of significance alpha is referring to probability of making the type 1 error. Okay, and it is chosen before the simple data are collected. So all these problems will actually give you the level of significance. Okay, they're going to choose that level of significance first before they begin the test. All right, so let's talk about these tests real quick. Okay, there are two approaches. Okay, so in a minute, once I'm explaining how to do the test, we're gonna test for population mean, where sigma is known. Just like when we did confidence interval, sigma is known, sigma is unknown. Okay, two approach. First one is called the classical approach, which is using what we so-called the critical value and the critical region. Okay, so I know this is kind of hard to see. All right, see the alpha right here? So this is a left tail test. Okay, this is a left tail test. So this alpha is referring to the area under the curve on one tail. Notice right here, when I use a critical value, okay, this negative z sub alpha, okay, is my critical value. Okay, so if my test statistic, okay, I gotta find the critical value first. If my test statistic fall into the left tail, then we will reject the null hypothesis. Okay, if the test statistic, okay, fall in this region, then we will fail to reject. Okay, So it's really about the comparison between the critical value and your test statistics. Okay. All right. This is a right tail test. So if the test statistic, not the critical value, if the test statistic fall into the rejection region, then we will reject, okay, the null hypothesis. All right. And this is this is a picture for the two-tail test. Okay. So that's one approach, is using critical values, okay, and test statistics. Another approach is called the p-value approach. P-value is referring to the probability of the critical region, which is the area under the curve. All right, very important right here. If the p-value is less than the level of significance alpha, then we will reject. Okay, so if you look at the x-axis, okay, two tail, left tail, right tail, this is not alpha, this is z sub null. Okay, so this is z sub null, so that z sub null will be my test statistics. Okay, and if the p-value, okay, is less than the alpha, then we will reject. Let me put it down here. We will reject the null hypothesis. So if the p-value, okay, p-value is the probability of the critical region. Okay, critical region are the rejection region. So if the rejection region, if the area under the curve of the rejection region is greater than the alpha that we set, then we say we fail to reject the null hypothesis. Okay. So if the area, okay, of the critical region is bigger than the alpha, that actually tells me that it fall under, okay, my test statistics will actually fall under the green part. Okay, all these pictures with the green part, they will fall under there. So we got two different approaches to do the hypothesis test: p-value and using our critical value and test statistics. Okay, so this is a little bit confusing because I will show you, I will try to show you using both answers. Okay, because these problems will ask you to come up with both p-value and the test statistic. Okay, so it should be the same conclusion no matter what, just two different approach of doing it. All right, so here are your criteria, okay, for hypothesis testing. Got to be simple random sampling. There should be no outliers. Population got to be a normal curve. My sample size got to be greater than or equal to 30. If not, then the problem will tell us that it's approximately normal. All right, so here are the steps. Okay, here are the steps of hypothesis testing. First thing we do is to determine what is the null hypothesis and what is the alternative, so we can figure out whether we are doing a right tail, left tail, or two tail test. Okay, that's the first thing we got to do. Then we got to select the level of significance alpha, which the problem will tell us that. Then we're going to figure out our test statistics. So here are the formula for the test statistic, and they all look very, very familiar because they are all coming from when we single this from the confidence interval. Okay, except some of these notation is slightly different. Okay, for when sigma is known, and I can show you this if you go back to chapter 8 on the formula sheet. Let's see what my chapter 8 is. All right, chapter 8. Okay, your test statistics. All right, these are the margin of error. Okay, So these are, oh sorry, chapter 7, central limit theorem. Sorry, I thought it was chapter 8, chapter 7. All right, the standard score. When we talk about the central limit theorem, okay, the standard score for the sample mean is x bar minus the mean of the sampling distribution x bar. So right here, this part right here, we don't say the population mean. We are actually saying mu sub null. Mu sub null means that is the what? This is the mean from the null hypothesis. Is what the null hypothesis is claiming. Okay, so the subscript here is different, but it's still talking about z-score, t-value, and our chi-square as well. All right. So you got to find the test statistics. Okay. Then, if you want to use the critical value and critical region approach, you got to find the actual critical value z sub alpha over z sub alpha over 2. Okay. And the critical value representing the maximum number of standard deviation that the sample mean can be before rejecting the null hypothesis. So this table 10.1, okay, is on the formula sheet where you can actually use this table to actually find your critical value. So let me go to 10.1. Okay, so if you scroll down, okay, after all these formulas, there's a table 8.3, 8.4, and a 10.1. Critical z value for the rejection regions. Okay, you got one tail and two tail. These are the same numbers when we talking about. Let me go down here. Let's see, where is it? See if I can find it. Nope, not right here. Let's go back up. It's the same thing as this critical value of z that we used before. Okay. When we did a confidence interval with the critical value of z, it was always two-tailed problems. Okay. So still call it, so rather than call the critical value of z, okay, these are critical z value for the rejection region. So these numbers, okay, one tail or two tail test will be in this picture. Okay, you'll be right here. You know, your x-axis are your critical z value, and that's why they call it the critical value, or critical region. Okay, it's wording coming from chapter 10. Alright, so we can find that real easy using the table, okay, or you can compute it yourself. Step number 5. Then we're going to compare our critical value down here that we just found versus the test statistic. If the test statistic z sub null fall into the critical region or rejection region, then we reject. Okay. Otherwise, okay, we fail to reject. So these two tail, right tail, and the left tail picture is the same picture as what I showed you earlier right here. Okay, it's the same picture. Alright, so when do we get started? Okay, we're gonna follow your basic 5-step. I will show you how to do this in the calculator too, okay? I will show you how to do this in the calculator as well. Alright, let's try this, okay? Remember now, this objective we are testing for the population mean where sigma is known, okay? Sigma is known. Alright, a manufacturer of potato chips would like to know whether its bag filling machine works correctly at 444 gram setting. It is believed that the machine is underfilling the bag. So they get a sense of that it is underfilling the bags. So, 39 bags of sample had a mean of 436. So the reason why they feel that it's underfilling because the sample 39 bags. Assuming the population dimension is known to be at 19. Alright. is there sufficient evidence at 0.01 level that the bags are underfilled? So, all right, so let me do this. Okay, we got 6 steps. Step number 1, state the null and the alternative hypothesis. So the setting, the null hypothesis is the mean is supposed to be at 444 grams. All right, but they are feeling, the researcher are feeling, which, so researcher are the alternative, they are feeling that it's underfilled. So they feeling that it's actually less than 444 grams. Okay, so when I do less than, this is gonna be a left tail test. Find the value of test statistics. Okay, we'll do that just in a minute. Step number 3. All right, less than, that would be what? It's a 1 tail or 2 tail test. That gotta be what? 1 tail test. Let me just highlight it. All right, to be more specific, which tail? Less than, underfilled is left tail test. All right, step number 4, find the p-value. Step number 5, identify level of significance, which is my alpha. So this answer, alpha, is already at 0.01. Okay, so now let me show you how to find test statistic and the p-value. Okay, we can actually find the test statistic and the p-value, okay, using the using our calculator. So about the only thing that the problem is not asking, okay, is your critical value of z. All right, so we will come back to this table just in a minute. Let me show you how to do this in the calculator real quick. All right, so if we go to stat, go to test, this word test is actually where we came for the confidence interval. So right now we're gonna do the z-test. This test means hypothesis test. Okay, so if you really look at the formula, let me go to the formula sheet real quick. How do I know right now I'm supposed to use z-test? Because when I use z-test, this is chapter 10, right? Test statistic. The reason why I'm picking z-test because my sigma is known, right? Because it told me what my population standard deviation is. So when you see this z right here, that tell you to use a z-test. All right, so I will pick number 1, z-test. Okay. All right. Data means I will actually type in numbers, but I didn't type in any numbers, so I'm going to go to stat, press enter, typing my mean. Okay, the mean for the null hypothesis, which is what they are claiming, 444. Enter. Standard deviation, they told me it was standard deviation known to be 19. So we're typing 19, press enter. All right, I also gotta type in the sample mean. What was the sample mean? The sample out of 39 bags was 436 grams. Enter, and it was from the sample of 39. Okay. And the reason why I need sample mean in the sample, okay, in the sample size is because on the formula sheet, the test statistic, okay, the test statistic is basically coming from the alternative. Okay, why do they feel the bags are underfilled? Because they took some sample and found out the sample mean, okay, is actually less than 444. So now you have to use those information to come up with the test statistics and see where does it fall, whether it's a rejection region or fail to reject. Okay, that's why we're gonna use the simple stuff. And we say this is a left tail test. So highlight less than, press enter, and we'll calculate. And what the calculator will give you, okay, this is Z right here is your test statistic. Okay, 2 decimal place that tell you the test statistics is at negative. Let me make sure I write my notation correctly. I don't want to write this thing down incorrectly. The test statistic Z sub null is negative, what was that, 2.63. Okay. This P is your P value, 0.0043, 4 decimal place. So my P value is 0.0043. Alright, so now let's make a decision to decide whether we will reject or fail to reject. So I'm gonna go take a picture of my left tail test real quick. I'll use this picture, okay? I just perform a left tail test, so I'm gonna put it right here. Remember now, this right here is called a critical value. This is called a test statistic up here. So negative Z sub alpha, because I'm doing a left tail test. So go to your table, one tail test, 0.01. Let's go down to that table right here, 10.1. On this page, okay, my alpha is at 0.1. I'm doing a one tail test, so that's 1.28. So being right here, it got to be negative 1.28. All right, so this is my critical value, negative 1.28. So where does my test statistic fall? Where does my negative 2.63 will fall? Does it fall in the critical region, or does it fall in the fail to reject? Well, negative 2.63 is actually smaller than negative 1.28, so it will fall in this region. So if the test statistic fall in the critical region, then we will reject the null hypothesis. That's my conclusion. All right. Remember, there was another approach using the p-value. Remember what I wrote? I wrote if the p-value is less than alpha, we reject. All right. What's my p-value? 0.0043. So is 0.0043 less than my alpha, which is at 0.01. Is it true? Yes, it's true. So we what? We reject. Same conclusion, okay, from either approach. This is smaller than that, so we reject. All right, and that's hypothesis testing. Okay, so basically, you can use the p-value to do this, or you can use the critical region and the critical value to do this. Okay, either approach will work to make the final conclusion. So once you reject the null hypothesis, then the actual conclusion go back to these things I highlighted earlier. If I reject, that means there is sufficient evidence at 0.01 level of significance. Okay. So I'm going to type it out one time, okay? So there is, if I reject it, so there is sufficient evidence at 0.01 level of significance. Alright. That the machine is underfilling. $444 grams. There you go. Okay, that will be the fully conclusion. Okay, so that's what's going on. Alright, so if we reject, there is a so what is our sufficient evidence? Our sufficient evidence is the sample we took, 39 bags, mean is 436 grams. Alright. Alright, let's try another one, okay? Alright, again, 6 different steps. Alright. An automobile manufacturer has driven its van a 43.6 mile per gallon rating. Has given its van, not driven, excuse me. Alright, so they are claiming, so this manufacturer is claiming the van can go 43.6 mile per gallon. An independent testing firm has been contracted to test the actual mile per gallon for this van, since it is believed that the van performs, what's this word right here? Perform over what the manufacturer is claiming. So, what's my null hypothesis then? Is what the manufacturer is claiming. They're claiming the mean mileage is going to be at 43. This is a mu. I'm sorry. This is mu, not kind of weird. The mean is at 43.6 mile per gallon. So the independent testing firm, okay, took a sample and believed that the van is actually overperformed. So so we are the testing firm. So we believe it's doing better based on after testing 190 vans. Okay. Be careful now. This is population variance. Okay. To be 4.41. So population variance is 4.41. So the population standard deviation, because that's what I need to type in here in a minute, got to be square root of 4.41. So we will type this in the calculator just in a minute. Alright, is there sufficient evidence at 0.02 level of significance to support the testing firm's claim? Alright. Find the value of test statistic. We did get that from the calculator. Is this a one-tail, two-tail test? Greater than will be one-tail test. To be more specific, it's going to be a right-tail test. We'll get a p-value in a minute. What's my alpha? Level of significance. Alpha is saying what? At 0.02. Alright, so let's punch this in, okay? Stat, test. Okay, since I know my population standard deviation, we will do the z-test. Okay, this time my mean that I'm testing is 43.6. Standard deviation, square root of 4.41. That's 2.1. The sample mean to be 43.9. Okay, after the 190 events, they're saying it's 43.9. That's why they believe, that's why they feel is overperforming. Sample size 190 event. Press enter. Go to right tail test. Enter. Go to conclusion. Draw means it will draw the picture for you. Alright, let's calculate. Voila. Alright, so remember now, this Z is your test statistic. It's at 1.97. your test statistics. 1.97. Alright, your p-value, what does it say? 4 decimal place, 0.0245. Okay. Alright, so let's make a decision. Okay, do we reject or fail to reject? So let me go take a picture of this right tail test. Where is it? Right here. Alright, let's see what is the fall. Alright, my critical value. If I want to do the critical value, critical region approach, my critical value alpha is 0.02, and I'm doing one tail test. 0.02, one tail test. The critical value is 2.05. It's positive. Okay, 2.05 right here. That's my Zisa alpha. So where does the 1.97 falls? Does it fall in a rejection region or fail to reject? Well, 1.97 is less than that, so it will actually fall in here. Fail to reject. Alright, so if we fail to reject, that means what? That means this independent firm did not find sufficient evidence, okay, at this level, okay, at this level, okay, to support their claim. So we fail to reject. We're not saying what the manufacturer claiming is true. It just the independent firm did not find enough evidence to support, okay, did not find enough evidence to support what they tested, okay. Their finding did not support. Alright, so again, is my p-value less than alpha? Is my p-value less than alpha? So my p-value 0.0245. Is that less than my alpha 0.02? No. So if it's not, then we fail to reject. Okay. All right. Let's do one more, then we will end right there, and then we'll pick back up with another with the part 2 of this chapter 10. A director of research and development is testing a new drug. She wants to know if there is evidence at 0.02 level that the drug stays in the system more than 357 minutes. Okay, so they take a sample of 49 patients and find out that the mean time the drug stays in the system is 364 minutes. Assuming the population deviation is 19, make the decision to reject or fail to reject. Oh, okay, so alright, before we can do that, let's think about this, okay? Alright. The problem never say whether so you want to know if there's evidence to support that the drug stays in the system for more than 357 minutes. Oh, okay, so she want to, so the researcher want to this lady want to know if it's more than 357 minutes. So that means the null hypothesis of the mean got to be at 357, and she feels that the mean is actually more than 357. The reason why she feels that way because you take a sample 49 patients, all right, and then the mean For the 49 patient, it was 364. Okay, so let's see. I think I got everything I needed. Alright, stats, test. Again, z-test, because I know my standard deviation, population standard deviation. Go down. So the mean that I'm testing is 356. The standard deviation is at 19. The sample mean turned out to be the 364. Sample of 49 patient, and this is a right tail test. Alright. So my test statistic is 2.94. Alright. Let me just come up here and grab this picture right here. Alright. My test statistics 2.94. 0.02 level, just like this problem, right? 0.02. The critical value is 2.05 again. Right. 0.02 alpha, one tail test. And my test statistic 2.95. So where does it fall? Does it fall in the critical or fail to reject? It does fall in here, right? 2.95 is bigger than the critical value. So that means what? We will reject. So the drug is claiming, the drug itself is claiming it will stay for 357 minutes. She is thinking, she feels that based on her research, it's more than 357. Okay, because the sample she found was 364. So it turns out that our test statistic will fall into the rejection region, so we reject the 357. Okay, so she did found sufficient evidence to support her claim. Okay. All right. You can do the P and alpha too. Is my P less than my alpha? I already wrote it down right here. Is my P less than my alpha? What's my P? 0.0016. Is that less than my alpha, which we decided to be at 0.02? Yes. Fail to reject. Excuse me. If it's yes, then we reject. Alright. Alright, we will take I will stop it here for right now. The part 2 of this 10.1 to 10.5, we're gonna do where population standardization is unknown, so the T value comes in. Okay, the critical value of T comes in, and we will test for population proportion P, and we will do testing for our standard deviation. Okay, the problems in the homework are very repetitive. Okay, they're all dealing with the same thing. The only example I did not do so far is two-tailed test. Okay, so we'll probably run into it with other example, and I will show you. Let me go back here real quick. Let me say something. Where is it? Sorry, I think it's these formulas. Where's my formulas? Okay. The test statistics. All right. So if you look at the test statistic here, okay, it tells you it kind of tell you what tests we're doing based on whether population standard deviation known or unknown, and you can see it in the formula sheet as well. Okay, I'm not asking you to do this by hand per se, but I do want you to look at, okay, why do I choose a t-test in a minute? Because the population standard deviation is unknown. Okay, and the degree of freedom will come back as well. Alrighty, thank you for watching this